The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody. Hello and welcome to our webinar. Thank you very much for taking the time out of your day to join us today. There's a lot of people on this call and there's a lot of information to go through. So you're all muted, but please, if you have any questions or issues, please use the questions box on the panel of your webinar application. But first of all, let me introduce myself. So my name is Simon Brand, and I am the sales manager here at Manor Machine for the manufacturing division. I've been in the industry working in manufacturing for many years and have got a lot of experience. So between myself and my colleague on this call, we should be able to answer most of your questions. First of all, let me introduce you to the company, to the millTURN Machinery Group, so which incorporates both Man and Machine in the UK as well as OpenMind, who are on this call. So we're a pan-European organisation. We really develop solutions for our clients and want to provide the entire CAD/CAM solution to them. We've got over 100,000 customers throughout Europe, and we're multiple specializations in multiple products. In the UK, we're known as Man and Machine. We have recently launched, we're really excited to have launched a new website, manandmachine.co.uk. There's lots of useful information and content from blogs to upcoming events and webinars like this one, to training, physical or remote or virtual training. Please, after this call, please visit our page and please feel free to bookmark and come back because it is regularly updated. We've got lots of scheduled webinars for the rest of this year. We've obviously added a few extra webinars over the coming weeks or couple of months because of the situation we find ourselves in at the moment. Please, if you are interested or in any of these areas, these are a great source of information for you to find out more about a certain topic or a certain piece of information. Please visit our website, the events page of our website, and please register straight from that page if any of these are of interest. Man and Machine have quite a wide software portfolio, and we offer advice and solutions around a number of key products. Autodesk is at the heart of most of the applications that we work with, and makes up a huge part of our business, and we are platinum resellers of all Autodesk products. But we also develop our own software. OpenMind is a wholly owned subsidiary of millTURN Machinery Group. It's a sister company within the UK, so it develops the HyperMILL product, which, as they are a sister company in the UK, it means it's very well supported, very well developed, and very well trained as a completely separate organisation. We also develop other applications. We have a team of talented software developers throughout Europe, developing software from product configuration to electrical design to data management tools, and these are all our own applications that we offer. But we also offer in the UK, have relationships with a few other software vendors, really so that we as an organisation can offer a true solution to our clients from start to end. It's allowed us to get lots of accreditations in the UK around BIM, BSI and CPD certifications, so you have the knowledge that you're getting the right information at the right time. But let me introduce you now to OpenMind. So my colleague Josh is on the call. He represents OpenMind, and we're going to be taking you through a product demonstration of the product HyperMILL. And there's a couple of key things we're going to be showing you. We're going to be talking to you about using HyperMILL to perform high performance cutting, to look at faster tool path programming, and to look at the hot topic of barrel cutters. So without further ado, let me hand you over to Josh from OpenMind, who's going to be taking you through the rest of the demonstration.
Yeah, so today we're looking at the high performance cutting. We're just going to be doing a couple of examples between sort of traditional cutting styles and what we call our max machining package with the high performance cutting. I hope you all can see my model on the screen.
Yeah, I can see it, Josh.
Square model, brilliant. Okay, so what I've got showing here in the middle, in this cavity, traditional style roughing tool, offsetting from the last boundary hit into a plunge point in the center. Typically, with this type of toolpath, you get heavy wear on tool, you get rest machining loops, you get full width slotting. All these can have a real negative effect on tool and the machine. With this type of toolpath as well, you're generally quite slow on feed and speed. You have helical moves into the material, which require axial forces going out of the materials. It's not ideal. I'm just going to run a quick simulation on this. Now, I've got this speeds and feeds from Iscar Tooling, and I'm treating this material as stainless steel around with a 16, and I'm not used. Okay, there is max machining in our cycles can be as simple as turning it on in the cycle and pressing calculate. So this will focus on producing. Tricoidal milling has various benefits. Okay, max machining is overall a better toolpath style, and it's far more consistent with the latest machinery capabilities. And this style of toolpath has even pushed tooling to produce better geometries. Difference is we use feed rate adaptation compared to the traditional high performance cutting, which is varying engagement. If I look at this toolpath here, the big spiral opening pocket and dense area, I'm not changing the engagement into the material. Max machining adapts the feed rate to maintain a constant metal removal rate. This results in constant cutting forces, which is the one, if not the most important thing in quick roughing operations, the removal rate. This not only produces constant machine loads, but can uniform the chip thickness. Uniforming the chip thickness can result in excellent heat evacuation into the chip instead of the tool. So we're gaining on tool life here. This style of toolpath is changing the way we machine. Combined with the constant feed rate, we are adapting the toolpath to use the full flute of the tool. Okay, using the full flute of the tool produces a much nicer scenario. We are entering grounds of using side radial load much closer to the holder. That, combined with a full depth of cut and a low radial engagement, produces a better scenario whereby the surface feed and even feed per tooth can be ramped up substantially, while keeping the cutting forces low to maximise tool life. High performance cutting paths from HyperMILL will generally have an overall shorter tool path, and you're machining the material faster. So it's win-win all the way around. So if I was to simulate how the material is removed using our high performance, okay, in this particular scenario, I still do have a plunge, but that can be removed. I can pre-drill a point So I'm using the full length of the tool and it's spiraling out, maximizing the flute length of that tool. So you get an equal wear, you're getting the most out of the tool possible. You can see the feed rate is constantly adapting to suit the scenario. There's a real nice function whereby as it's entering the material, it actually slows down so you do not shock the tool. That's very important when you're machining hard materials. Once it's engaged into cut, it then speeds back up. So this is feed rate adaptation, not engagement. In this little pocket here, I did set up an example as well where actually I did pre-drill a point in the middle and used high performance there, which also produced better gains, and I'll show you the difference in a moment. Okay, because this is the nice way to get this set up. Okay, so with this toolpath, I've already pre-drilled a hole. Maybe use a U-drill, something smaller. Means I can plunge straight to depth and I do not get the helical move, and I'm straight into the tricoidal. Really maximizing what that tool can do. So I'm just going to show statistics wise. Now this is using recommended speeds and feeds for the traditional toolpath. 52 minutes for this pocket. Granted, it's quite a large pocket. Okay, and I'm treating it as stainless, so yeah, there's going to be here we go, it's a 160 odd mil pocket. So 52 minutes to rough that out. Using high performance statistics, over 50% in that pocket, less. 26 minutes now, 26 and a half minutes cam time. So huge advantage there. Plus, not to mention, nice scenario on the machine. It's lower cutting forces, and you're utilizing the tool better. There's geometries out there now from several manufacturers that have real specific designs and helix angles on these tools and chip breakers that really do optimize and allow you to achieve faster surface speeds. On this example here, the traditional style toolpath, we were running at 62 surface speed and 50 microns per tooth. For the tricoidal, I can run at 98 surface speed and 80 microns per tooth. So that's a factor of 1.5 or 1.5 times on VC, and over 2.5 times faster, more metal removal on the FZ, on the feed per edge. So massive gains to be had there. This style of toolpath, okay, it was originally developed for hard materials, but it can be utilized in softer materials as well. Tooling, again, is allowing that scenario to happen now. You know, the original idea of this sort of high performance max toolpath was for harder materials, but I say tooling geometries these days, it's really enabling us to use this max machining in all areas, which is really quite nice. So if you have got any questions on that, save it until the end. Okay, I'm just going to move on to a slightly different aspect now. I'm going to use the same part for now, just because it's got a nice little section on it. And I'm just going to focus on these slots. Okay. When we're doing Z level or constant Z based cycles, you get typical scenarios whereby in this open slot case, the tool will naturally want to wrap around the edge. Okay. You get this, I've done it up here as well, wraps around the edge. Now, it's unoptimized. you can, if you had a stock scenario inside that pocket, you know, that's going to be gouging in and you know, this is causing pre-machining to occur. Takes time, takes effort. We do have tools, of course, that can help. We have our extend and shorten face command, which is a real nice solution for extending the surfaces out, and it can eliminate the wraparound. But HyperMILL cycles are developing rapidly, and we have options in our cycles now where we actually get automatic surface extension occurring. We are bringing in HyperMILL functions into the cycle for an automated result. Quick, simple, saving time. And if I was to just press calculate on this now, a nice thing here as well is I've actually, instead of creating boundary curves and controlling the tool using boundaries, I've selected milling surfaces. I've said, no, just mill these surfaces. And through that selection, I've got an automated surface extension, which is done by a formula. So this allows several types, all types or sizes of tool to achieve the same result. So you can see now with that surface extension, again, optimized tangential entry and exit out of the material. No wraparound. Really nice there. And that's just an option. Yeah, you just pick your surfaces and hey presto, milling surfaces mode done for you. Marvelous. I've actually got another scenario for this. Okay, now this is obviously quite a hefty part, but I'm just using it because it shows the power quite well. Z-level style toolpath down this cylinder. You get the wraparound over the top. And yes, you could offset the top face a bit and stop it rolling over, but this is all time and effort. This is all being controlled now within the cycle. I select my face that I want to machine, press OK. I get my surface extension all the way around. I press calculate. Okay, now I'm using the same sort of step overs and whatnot as the previous toolpath, but you can see it's completely eliminated the wraparound in this area. So again, really nice, powerful solution here. So it's not just for Z-level areas. We do have the availability also in flat area machining. So the profile finishing side of things. Traditionally, you get the tool rolling off the edge. Okay, and again, to stop this, okay, you could set a boundary, but if you set a boundary to the edge of the surface, you're entering grounds of the machine speeding up and slowing down, doing step over all on the part, which, yeah, you can improve certainly in open areas by having an extension off of the surface that you're machining. You get much better edge behavior, and you're maintaining surface speed correctly when you're milling those surfaces. So again, we have a nice scenario where I can use milling surfaces for my selection. I can say, yeah, I want to mill these surfaces, okay. And instantly, yeah, automatic surface extension, I've placed it all around the edge. And if I calculate, you really see that extension covering that area really nicely. I'm starting off the job. This also helps, you know, when you're doing 5-axis machining, when you're taking the tool off, just gives you proper lead onto the material, exiting the material properly. Really nice result there. Okay, just wet the whistle a second. Okay, so yeah, so a number of cycles have this surface extension, including the barrel milling. Okay, Ken mentioned the barrel milling earlier. and I will come to it shortly. But I'm going to return back to this part and focus really on where you use barrel tools. Okay, barrel tools are there to help us machine what we would call hard to reach areas. Okay, tight corners, deep pockets, things where your ball mill or end mill would essentially have to be sticking out substantial amounts, and you're getting an optimized result because you're going right on the tip of the tool, and you're getting push off, vibration, that type of thing. And tight corner areas where you really start having to step down the tool size. So we've got a scenario here where I've got a little 4.2 mil radius corner, thin wall section on this aerospace part, and quick measurement of how deep I'm trying to go. Roughly 55 mil for an 8 mil tool. So yeah, you'll be getting maybe a bit of push off on that. We want to look at tangent machining. Okay, so our tangent machining is utilizing conical barrel tools, and you're looking at using this large barrel radius edge. Now this contacts the part with quite a large engagement. Okay, it's a massive radius. So using 3, 4, 5, 6 mil step downs, honestly you cannot feel the difference. It's beautiful results. And because we've got a small ball on the end, we can utilize that for finer detailing. And being tapered, we can achieve much thicker shank, much shorter stick out of the tool. So optimizing the result in every aspect. Okay, compared to a standard ball nose. Okay, so standard ball nose in here, you'd be scanning maybe a 10 mil, maybe a 0.2 step down for this. In this cycle, we're honestly really achieving a 5 mil step down, and it will produce lovely, lovely results. And because you've got a thicker shank on the tool, shorter tool holding, speeds and feeds are increased. Okay, you can ramp it up. You start taking and pushing the machining to its limit. Okay, with ball noses, you're limited really not only by spindle speed and whatnot, but by the stick out that you have to have and the vibration. So something nice happening right now. Okay, this is bounding toolpath. Okay, something specific to HyperMILL. You do not get it anywhere else with barrel tools. Typically, when you're machining the plane along here, in this corner right now, it's going to leave a tiny little wedge of material. It's like you can feel it, you can see it, but it's nothing substantial. But that typically has to be removed in secondary operations. We've actually got very easily, you pick the bounding curves of the surface that you're machining, and we get the automated fillet bounding path that clears up that step. So just run that down through here. Okay, and you saw the angle change of the tool there. It adapts it to suit the scenario. So this is I think I've done a 16 mil shank on this tool, and you're getting into tiny little tight areas, corners. It's something incredible. It really is. But it's not just planar surfaces that you have to do. You can do freeform surfaces. Okay, freeform surfaces. And these geometries are becoming much more difficult, complex to machine. Certainly, in the medical industry, I'm currently doing a part where I'm doing a medical knee joint, and these sort of complete freeform surfaces, but barrel milling, we're looking at massive, massive gains compared to the conventional ball nosing of these surfaces. I have a scenario on the inside where I'm using the same barrel tool to machine all the way around these surfaces, and HyperMILL does a very good job in limiting the amount of axis you need. Okay, just because it's a 5-axis cycle does not mean it will use all 5 axes at the same time. It only uses it when it needs it. Okay, machine stability is a massive control. It always looks great on cam, but when you put it on the machine, you think, look, yeah, what's it doing? Okay, we do a very, very good job in only using what we need. Okay, so, you know, really deep wall pockets here, completely collision checked, lovely result in there. I have a question about I mentioned the ball of the barrel radius earlier. You can implement it, okay? I've added in some passes using the barrel mill, but I'm now utilizing the ball, not the major radius. So you can start to tickle out these corners and radiuses all using the same tool. Okay, so you're utilizing all of the tool here. And again, lovely clean results going on here. Okay, guys, I think that's me.
Thank you, Josh. Josh, that was really, really useful, really interesting.
Good.
Thank you very much, and thank you, Ken, for your introduction. If anyone has any questions, please use the questions box for Ken or for myself or for Josh, of course. Please use the question box. Josh, we have had a couple of questions come in, actually, while you're presenting. I don't know if you, either of you can answer. So there's a question on the barrel cutters. They look really interesting, and who sells them? Where can you get them?
Yeah, okay, so yeah, a couple of tool providers provide these. To name 3, we've got Imuki Franklin Tools, Quick Grind in the UK. They're really good. You know, good for getting your custom sizes, because you know barrel tools, they come in all shapes and sizes. They have their standards, but standards don't always fit the requirement. So you do need to sometimes go for custom geometry. So Quick Grind, Seco tools, they're great for that.
Okay, lovely. And there's also a question about can you select multiple surfaces, or have you got to join surfaces together before using them?
Okay, so it does depend on the geometry. Okay, for instance, this scenario over here. If I was trying to machine that surface, the tool would naturally want to retract at the hole and come back on. Okay, but this is an unoptimized result. So, you know, here I've quickly drawn in a bounded plane, okay, which just covers this area, and I can machine to that. So you just select that surface in the cycle. When you're talking about joining surfaces, okay, let's, for instance, in this one in this pocket here. Okay, these are all separate surfaces that I've manipulated quite easily and joined into one surface. Okay, you can go across surfaces separately. If I was to maybe open up a separate scenario that I've got hidden away. We have several scenarios on this part where, yeah, we've got one nice surface, one nice surface, one nice surface, patchwork quilt. Okay, so this is somewhat a difficult scenario to deal with, because certainly even if you're scanning these surfaces using a surface-based cycle such as ISO machining, each surface has a different ISO orientation. So then you get patchwork quilt machining. Something really nice, I suppose, is in tangent machining, and it's an actual CAD tool as well. It's called global fitting. We've integrated that technology into a cycle whereby we can say, look, I'm trying to machine all of those surfaces. They're all going different directions, but I need a drive surface. And this cycle, tangent machining, utilizing the barrel tools, is doing that for us. Okay, I get my surface extension. I get to choose whether I'm running along the surface, down the surface. And if I just press calculate on that, so it is as simple. I've picked a tool, I want global drive shape because that's the function that gives us the utilization of normalizing my ISO directions, and it's got automatic drive shape extension. So now, and I'm really utilizing that barrel now in a really nice, efficient manner. So to answer your question, a lot of the time you can get around different surfaces, multiple surfaces in one operation. You don't have to machine them individually. We have the power to globalize the machining direction over those surfaces. We can treat it as if it is one surface. But by utilizing the global fit function, that's automatically implemented into the cycle.
Well, wonderful. Thank you, Josh. That's really, really useful. There are some other questions. I'm conscious as well that we're taking up a lot of everyone's time, but I guess we'll try and answer some of those questions, offline.
Yeah, of course.
But I guess what happens from here? If anyone on this call is interested or has any more specific questions or wants to get in touch and find out more about HyperMILL, I guess get in contact with either Man and Machine if you already deal with us, or with OpenMind Direct. I think that would be the best way forward. Would you agree, Cam?
Yes. Yeah, that'd be fine. Yeah, you can get our details on our website, openmind-tech.com.
Lovely.
Okay, guys.
Well, thank you all for your time. Thank you all for logging in, John. Hopefully that was useful for you, and we'll try and answer some of the questions offline afterwards, if that's okay. David, I've just seen your question come in as well, but we'll come back to you direct after this, if that's okay. I'm conscious not to take up too much of people's time, but thank you all for your time, and have a good Friday and a lovely weekend. Take care.
Stay safe, guys. Thank you very much.